Thevenin's theorem. We want to solve the numerical problem by using Thevenin's theorem, considering dependent source. So in case of the dependent source, it may be current source or voltage source that should be remain in the circuit. So for determination of RThevenin, you have to calculate both open circuit voltage or Thevenin's voltage and short circuit current ISC, or you can say that as a I Norton also. That is the I short circuit current and V open circuit voltage. So by using these relations you can determine the RThevenin resistance. Now say first problem is like that. The circuit is consist of one independent source and one, okay, just a minute. One dependent source So the problem is like that. You have to find out the equivalent circuit across the terminal A and B. So for the solution, first you convert this current source to an equivalent voltage source. Current source to equivalent voltage source. So after conversion, the circuit will be look like that. And this is the standard formula or standard method you have to apply it for current conversion to voltage conversion. That is, in case of current source, that this is a current source and parallel with this resistance, and after conversion it will be converted to a voltage source connected one resistance series with this source, and that is the same resistance for the current source. And what is the magnitude of this voltage source? That should be I into R, that is 4I into 5. This is the magnitude of voltage, that is 20I, and that magnitude of the voltage, that is dependent of current flowing through this 4 ohm resistance. So in this problem that is given is current dependent current source. Now for the circuit solution we converted this to equivalent voltage source. Now it is current dependent voltage source. Now if I apply KVL, if I apply KVL. What is our KVL? What is our target? Our target is to determine V Thevenin or V open circuit voltage. This is our target to determine V Thevenin or V open circuit voltage. Okay. Now if you apply the KVL in this loop, that KVL equation is minus 12 for this loop. Minus 12 plus 4I. This is also same current flowing through this, that is 5I, and this is plus 20I is equals to 0. And after solving this, we can get that current I is equals to 0.414 ampere. Now what is the voltage V Thevenin or V open circuit? This is the V Thevenin or V open circuit. Sorry, mistakenly we represent that resistance here because already it is converted. Now V Thevenin or V open circuit, that equation is equals to 12 minus 4 into I. So that is equals to 12 minus 4 into 0.414, that is equals to 10.34 volt. So this is the value of V Thevenin or V open circuit voltage. Okay. Now we have to determine what is the short circuit current. So for that, for finding short circuit current across the terminal AB, you have to represent that circuit in that way. Terminal A and B is shorted, and we consider that previous circuit before the conversion. So this is the circuit. This is 4 ohm. This is 4I, and this is I. This is plus minus 12 volt. This is 5 ohm. So for finding the current, short circuited current, we represent that by a short circuited, this two terminal is short circuited, and what is the current flowing through this terminal, that is known as the short circuited current ISC. So now you see, if you see in this case, what is the value of this short circuited current? So ISC, that should be summation of I plus 4I. If you apply the KCL in this junction, that is the short circuited current ISC. So ISC is equals to that. If you apply the KCL, current entering into the node is equals to current leaving from the node, that is I plus 4I, that is equals to 5I. And already we calculated that I is equals to 0.414 ampere. So if you put this 5 into 0.414, that is equals to 2.07 ampere. And after getting this ISC, and already we calculated V Thevenin voltage is equals to 10.344 volt. Now you can able to calculate R Thevenin. R Thevenin is the ratio of V Thevenin by I short circuit current, that is 10.344 divided by 2.07, and that value is equals to 4.997 ohm. So in that way we can convert that Thevenin's equivalent circuit across the terminal A and B. So across the terminal A and B, now you can represent that as a equivalent circuit as like this: V Thevenin and R Thevenin across the terminal A and B. That is, V Thevenin is 10.344 volt and R Thevenin is equals to 4.997 ohm. Okay. Now we consider another problem related with this dependent source. That circuit is like that. So R1 is given 4 ohm, R2 is given 2 ohm, and current flowing through this R1 is denoted as IA, and this is a current source 3 ampere. This is a voltage source 16 volt, and this is current dependent voltage source, that value is given 4 IA. Okay, so you have to find out the current passing through the R ohm resistance. You have to determine the current passing through the R ohm resistance using Thevenin's theorem. Okay, so what is our target? Our target is to find out the current flowing through the R ohm R1 resistance using Thevenin's theorem. So for that case, first you have to determine Thevenin. So first thing is determination of Thevenin. So for that case, if you mark this terminal as A and B, so first you remove that load resistance from the terminal A and B, and that circuit will be look like this. So after removing that resistance R1, current flowing through this terminal is 0. So due to that reason, there will be no such existence of dependent voltage source, because it is depends on the current flowing through the R1 branch. Now you have to find out what is Thevenin. Okay, so this is our target, to find out Thevenin. So first you calculate what is the potential of VA. Potential of VA is equals to 16 volt, and potential of B, which is that voltage drop across 2 ohm resistance, that is 3 into 2, that is VB. Potential drop across 2 ohm resistance, that is 3 into 2, that is 6 volt, and VAB is equals to VA minus VB, that is 16 minus 6, which is equals to 10 volt, and that is actually equals to Thevenin. So this is the value of Thevenin, that is 10 volt. Okay, now for finding Thevenin, you have to determine the short circuit current. Okay, so find the short circuit current. You have to replace that 4 ohm resistance 4 ohm resistance by a short circuited path. So now the modified circuit in this condition will be look like this. So this is 3 ampere, this is 2 ohm, and this is I, short circuit current, and previous notation this is represented as IA, and this is 4 IA, and this is the voltage 16 volt. Now for finding this short circuit current, I assign a circulating current in this way, I1 and I2. Now if you apply the KVL equation, in this outer loop, if you apply the KVL equation, so we can write that 16 16 minus this 4IA, which is equals to that potential drop across the 2 ohm resistance, that is 2I2. Also we can write that what is the relation between IA and I1, that is IA is equals to I1. Now if you replace this, that will be 16 minus 4I1 is equals to 2I2, and if you rearrange or this equation, we can write that as a 4I1 plus 2I2 is equals to 16. Say this is the equation number 1. And similarly for this current source, we can write that in this direction I1 and in that direction I2. So if I write the equation for the current source, so for that case we can write that as a I2 minus I1 is equals to 3 ampere. This is, you put that equation 2. Now by using this equation 1 and 2, after solving equation 1 and 2, we will get that I1, which is equals to 5 by 3 ampere, and I1 is nothing but a this short circuited current ISC. So I1 is equivalent to ISC. Now already we calculated Thevenin, and now this is the value of I short circuit current. So from that we can able to calculate Thevenin, that is Thevenin is equals to Thevenin by I short circuit current. So Thevenin is 10, I short circuit current is 5 by 3. What is the value? The value of Thevenin is 6 ohm. Okay. Now what is our target? Our target is to find out current flowing through the RO, that is the resistance R1. So after conversion, that Thevenin's equivalent circuit will be look like this. It is consist of Thevenin, and again you have to connect a load resistance, and here load resistance is the R1 4 ohm, and this is Thevenin 10 volt, Thevenin 6 ohm. Now you assign a current IL which is flowing through this resistance R1 also. So if you assign the current, that IL is equals to 10 by 6 plus 4, that is 1 ampere. Okay, so this is the two representation of the solution of the two numerical problem using Thevenin's theorem. One thing you have to keep in mind, if the dependent sources exist, so you can't remove the dependent source from that circuit. So for the determination of the Thevenin, you have to calculate both open circuit voltage or Thevenin voltage or short circuit and short circuit current ISC, and ratio of these two will give you the Thevenin. Thank you.